Okay, yeah, I think this one is fine. Yeah. Myself. Okay. Upload. Can you my screen?
It's not the full screen mode yet.
Okay. So here you go.
Okay, yeah, perfect.
Okay,
yeah,
good.
Floor is yours.
All right. Okay. So okay, I'm starting now. Can you hear me? Okay. Thank you very much, Fumiya, for a nice introduction. And yes, I'm missing our drinking time, and I'm happy that I'm happy to present my talk today. This is my kind of new work, which is offloaded mind, the experiments of direct humanoid-human interactions. And the research is supported by JSP Skakenhi, promotion of integrated research in AI and brain science, which is by Ken Jidoya. He's in OIST. Okay, today's my topic is starting from emergence, and then to the cognitive, to the inactive, then to the offloaded mind. Okay, so first chapter is emergence. Many people ask me what is artificial life. Then my answer is artificial life is to make a theory of brain and evolution. So here is one of the example that I can show you that I did the simple chemical reactions of oleic anhydride in high pH water that they start to move to make a shell and then start to spontaneously moving around by itself. So this is like soft robotics that I've been discussing with many people. And Martin and I was quite happy to find this. It's 100 micrometers, but still can move around and sensing the pH gradient and then go to the high pH regions and also coming back to the lower one. However, so that's the starting point, right? So I did this one like 10 years ago, but then the Rodney Brooks, that he wrote a paper saying, these robots and programs never becoming live. Yes, I noticed that. So we've been discussing, what's the problem is. Maybe, the complexity that we discussed yesterday was still it's low, or maybe the computational power is not good enough, or maybe, we just missing the parameters. So maybe there's a right set of parameters, and we still have the wrong parameter set. Or maybe the fourth reason is we still miss the fundamental theory of life. That's why you can't make the real life from robots or programs. So I want to find the missing piece, and then that becomes the mission of artificial life. And then this is looking for the Brooks juice. So when I invited the Brooks to the conference of artificial life in 2018, which I hosted, I asked him, "Can you discuss, about the Brooks juice?" So this is my little, installation. And then he came to my installation and saying, "Oh, what's the Brooks juice?" Right? Because he didn't know that we call it Brooks juice. But so the Brooks juice is something like the last, drip of juice, right? And then this is a Roomba, and if we put this Brooks juice, then it becomes life. So what's this lemon? What's the final missing pieces? So this becomes the mission of artificial life. And then the mission of artificial life is try to find out what's this Brooks juice is. That's what we are doing now. Okay. So when I brought my oil droplet and then showed to Hiroshi Ishiguro, I think he's going to be the keynote tomorrow, I think. And then he said, "Okay, Takashi, it's interesting, but nobody understands it, right?" And then, so I was a bit embarrassed, but I listened to what he was saying, and then, okay, so give me your Android and I can make it live, right? So we are very much kind of opposite approaches. I'm from the bottom up approach, and Hiroshi is from the top down. So we start to collaborate since 2016, and we wrote a book which is called In Between Man and Machine, where the mind exists. Unfortunately, this one is only in Japanese. I hope somebody can translate. But since 2016, sometimes working with new Android, and then try to make it new, try to find out a new kind of principle for making robot. And then first one that I made with Hiroshi Shiguro is this Android called Alta. Alta is from alternative state of mind, and then Alta one, I implemented three architectures. One is coupled chaotic oscillators, like Kuniyoshi explained yesterday. And then the second one is a autonomous sensory network. This sensory network is a sensor, it's an independent module that get the information and send it to the architecture of Alter. The third one is a principle of stimulus avoidances. And this is we found with spike neurons, an artificial, and also the biological neurons. So that these three ingredients, the first approach is architectures that I input into the Alta to make it lifelike. In very simple words, the principle of self-stimulus avoidance is uh, think that this vehicle has a neural network inside, right? But it's plastic and then has a heavy learning. And then he's bumping onto the wall, then this is stimulus is coming from the wall. But if this robot has some trial and error actions, then by accident he could avoid bumping into the wall, then it retained. So he somehow try and then try to avoid stimulus from the outside. That's the idea of stimulus avoidance principle. So using this one, you can have a very interesting learning capabilities, implement learning capabilities. If you want to know the details, then you can go to these papers. And system of autonomous sensory network is that there is some artificial chemistry is going on. So there's an input from outside, like temperatures or humidities or sounds or vibrations. All this kind of stuff is coming into this one, and then some artificial chemical reactions going on. Then it send it to the auto and then other main parts. So this is a complicated sensory network. It's around auto. And the third one is a strange type of chaos. It's a chaos from the quasi-periodic flows. So if you have a high-dimensional quasi-periodic flows, so weakly coupled each other, once you perturbate those periodic oscillations, then it's breakout and then making some chaotic behaviors. So it's changing from the parameter from the right. This is a dot is a fixed point to the chaotic strange attractor on the left hand side. It is starting from this, we call it Newhouse Real and Tarkin's theorem. If you're interested in, just go to these references. Okay, so the first author blueprint is like this. We have independent sensory mode and autonomous sensors on the left, on the left. Then there's a CPG, is as I said, it's a quasi-periodic chaos from the quasi-periodicity. And then neural network has a PSA, is short for principle of stimulus avoidances. So there's the flow from the outside, and then there's the reactions, and then the order moves. Order has a 43 degrees of freedom, and then each angles and joint angles has a air actuators. So these informations and the computation through the neural network is transformed onto this air pressure compressor values, then send it to the 43 degrees of freedom. So when I did this, the one of the interviewer from I think from UK. So I played this one.
Meet Alter the Android, a robot with artificial intelligence so advanced that his creators claim that he has free will. The new humanoid robot interacts with people and moves through an embedded central pattern generator, or CPG, which allows him to express a wide range of different motions. The secret of the CPG is that it's designed to work almost exactly like a human brain. The CPG has its own neural network that mimics human neurons, allowing the robot to create movement patterns of his own, influenced by sensors that detect proximity, temperature, and humidity. The setup isn't quite at the level of creating human-like movement, but it does give the viewer the very strange sensation that this particular robot is somehow alive. Alter the Android is a further demonstration of the progress of artificial intelligence and robotics, and may be similar to the robots that we can expect in the future. If you want to catch Alter before he goes, he is on display for 1 week at Japan's National Science Museum in Tokyo.
Okay, after 4 years, he's still there, right? So Ota is in American Science Future Museum for Future Science, and then I didn't say that he has a free will, right? I mean, this interviewer says that I said, but we're struggling to make what makes free will, and then how it becomes, more adaptive to the environment. So the story goes on from here, right? And okay, so this prediction and the cognitive thing is that what is what was missing. So the first part is emergence. So we just artificial life discipline robots. So we didn't take into like a prediction or representations of a self model or world model or even planning. And then yesterday, that Juntani, Andy Clark, and then other people discussed, like using free energy principle, like Carl Friston's and then Andy Clark also, right? So this is what cognitive properties, and they need it to understand, cognitive behavior of a robot. Well, to me, um, I 50% agree with that, right? Only with the emergence, it's difficult to get the prediction or planning, right, which people think is the cognitive. So I tried to redesign the Alta, which is now called Alta 3. And then thanks to the Mixi Corporation that we did new design. So in 2016, we have Alta 1, then we have IR sensor, um, chaos, and then um, PSA, self-avoidance, and then, but we didn't have any self-images or self-awareness, um, dreaming mode or memory. So Alta 2 and 3, especially Alta 3, um, tonight. Kumia, is it working now?
Yes, I can hear you now. Yes, I just got cut off for a couple seconds.
Oh, really? I see.
Yes.
It worked now, right? Okay. So it's motivated from the Otto Wessler's artificial cognitive map, and then also as famous Peter Dyan and Hinton's and Rutherford's Helmholtz machine paper. Okay. Um, so the basic architecture of Alter is like this. Um, First of all, we have a memory, we have a automatic mimicry capacity, we have a self simulator, and then we have spontaneous dynamics. So these four ingredients is integrated, and then the core part of the Orta 3. And then there's a mode selector. So we have two loops. One is uh, getting the human's pose from the eye, Orta's eye, and then send it to these systems. And then he tried to extract the bone structures from this visual image, and then try to execute the structures with Otto's behavior. But once it doesn't work, he goes to the memory structures. In the author's memory, all the poses are recorded for many hours, so that he's trying to explore whether there's a adequate poses that is better than the one that he's trying to execute. So the left hand side is a memory loop. The other one is a direct imitation loop. So these two loops are the things that the core loop of the system. There's a two sensory inputs. One is from the human. So there's a human interactions with this thing. So author is, as I said, getting the poses from through the eye, author's eye. Then the pose bone structure is extracted and then do this. But yeah, that's what we do. The second one is a proprioceptive sensors, but this one is now in progress and maybe going to be installed in Auto 4. I hope. So for the memory structures, I used Darwinian evolutions. So memory structures, each unit is like 3 seconds, and then it becomes like a selection unit, right? So when you retrieving from the memory strings, picking up the memory pattern, and then it tested, and then it bringing back to this memory store. But when you do this, there's a noise is coming from the neurons that's is generated from the spiky neurons, which is exhibit neurons. It's coupled together, and then we use a principle of self-avoiding stimulus avoidance. So the things we have to you should remember here is that there's a direct imitation loop and a memory loop. So if direct memory loop is not good enough, then go to the memory loop, and then evaluation is by the optical flow around the author's the human's pose, and then also author's pose, and also if nobody is in front of author, but still the author is working with the memory. So picking up randomly from the memory stores and then apply it to his body, and he plays it and then bringing back. But then it's always mutated and then crossovers. So the mutation, memory structure itself is evolving, right? And that is going to be the source for creating new actions. So here is an example how this author works. Okay, so as you see here, that imitation is not perfect, right? Sometimes they fail to do this, but sometimes they come back. And then fluctuation is mainly caused by this neural network noise from the exhibit neurons. Now, so I'm using the time evolution of UMAP, like a uniform manifold approximation, and projecting onto the projection, and then try to use how the author's behavior changes over time. And the red spot is corresponding to the memory retrieved patterns, and the blue one is a direct memory imitation patterns. As you see, sometimes the red one is going up, so it's not just mimicking the behavior, but gradually they are making the new patterns, which is represented by the red ones. So this is like a summary of how it works. So there's a two mode. One is awake with human, and then memory with or without humans. So once there's when there's a blue one is the main part, is that there's a human in front of the author, and the author is just imitating the behavior. But when there's nobody in front of him, then there's only the red patterns, because it's always using memory patterns to generate his patterns, right? Um, One of the interesting point here is that um, when the author is successfully imitating human pose, then when we make measure the transfer entropy, and always the information flow is from human to author, because author is successfully imitating, and then human's pose is always upstream of this information flow. But when author fails to do this, human is it tend to help author to imitate its behavior, so that now the author becomes upstream of the information flow, and then a human becomes downstream of the information flow. So this switching from the upstream and downstream of information flow is the interesting um, evidence of this interaction is not one side, but it's a both side. Now come to the inactive part. Okay, so I think it should be that's this quote is from the Francisco Varela, the Embodied Mind, MIT 1993. It's a very famous book, which also very much um, educative and also implicative. So, and it says it should be recalled that embodiment, in our sense, for Merleau-Ponty, encompasses both the body as a lived experimental structure and as a context or the milieu of cognitive mechanisms. The people are, putting so much stress on the latter part, but I think it is very important to think about the body as a lived experiential structures. So that's something that I think as a in terms of inactiveness. So when I'm talking about the inactiveness, there is two things. What I'm thinking is, one is Trevarthen's very interesting paper he published in 2008, which is the musical art of infant conversations. The newborn babies still human. It's already like a protocol. There's a consciousness there, right? To share, as he said, polyrhythmic mimetic rituals, and then it's synchronizing, desynchronizing with each other. And that tells us the elaboration of the flow of consciousness itself. That's what he says. And also, as this one says, acceptance of these abilities of infants for intersubjective communications places cognitive processes of all kinds, including those that make sense of music in a different light. The human mind is not simply processing information related to the stimulus of the environment that may be perceived as a goal for the individual purposes. So I just want to know what is the exchange between human and human? What can be exchanged between baby and mother? And that was the motivation for me to think about interaction between human and robot, or robot versus robot, or human versus human, right? We're not just exchanging useful information between us, but there should be something else, right? And then also the Nadal, she is a very, very interesting psychologist, and she said uh, there's a when the kids are playing with each other like a mutual imitation game, there's a non-affordance way of using object got emerged. So I think it was interesting that the imitation is not just imitating others. Imitation is try to um, devise new way of using tools, right? So that's something I think. So people think the imitation doesn't go anywhere because it's just copying each other, right? But actually, what happens with human interaction is that imitation can be the source for devising new behaviors and new actions. And then me and Hiro Izuka at the Hokkaido University, that we've been working on this, like how the turn-taking behavior emerges from the little vehicles interacting with each others. Like this is kind of how this little small robot has um, devising new behaviors, even though they have to take turns, and then imitation is emerging from it. So well, this one is a connection between turn taking and then mutual imitation is related to each other. Okay, so for this purpose of inactive interactions, I have we try to interact order and order, right? The order 2 and order 3 interacting with each other. But at the same time, I also wanted to do possession experiment. Possession is that the human is controlling order, right? So what we do, how we did this is like this. First of all, put an Oculus crest on your head, and then see your hands through the Otto's eye, right? So that you can get the sense of ownership by looking your hands. Then execute how your body motion is synchronized with Otto. Then you can get the sense of agency. And then fourth, interacting with other Otto possessed by your friend. So that's the schedule that we asked subject to do before you interact with others. So in here, that my little elast tells you that the human subject is coming, and then we use the Kinect as the eye of the author that extracted bone structures. This yellow part is the self-simulated memory and an action, but when the possession situations, extract bone structure goes to the action without judging whether it's good or not, right? Then the author moves. But for the autonomous alter case, this self-simulator and the memory and action is executed. So this the direct imitation loop and the memory loop is still in progress. So this is still unpublished work that we are studying this now. So I can give you how it works. So this is the autonomous mutual interaction between alter and alter. Okay. So this author is imitating each other, right? Okay. So next one is a human possessing case. Okay. So the people behind this altar is possessing altar. So my question is whether you can see the differences between autonomous program interacting with each other, performing mutual imitation game, and then also non-possessing case and the possessing case. So this one is another case of possession. So this subject is more doing a discrete action behavior. So it's easy to see whether it is possessed, and then also whether the imitation goes or not. So there's a little latency between author and then subject, so that behavior is not quite synchronized between human behavior and then author's behavior. And then the free interaction between the author is in this case, this one is not mutual imitation. It's more like a free interaction between two people. も今見えてるのと同じ感じのでそれからどうなんですか So they started to do some imitation. Yeah. So it's quite, I thought, interesting. First of all, there is differences between autonomous program versus autonomous program, and also possession case, possessed author and possessed author interactions. So we just want to see this is like a Turing test of the embodied case, right? It's not by the language, but the embodied interactions of the Turing test, so whether you can distinguish between human versus program versus program. And so this is the autonomous case that still you can see the difference. There's a turn taking. I mean, when the author moves and the other one also moves. So this is very normal. But when we use like a UMAP representations, then it's clear that human possession author interactions is different from author autonomous program interactions. Well, you can easily say that, well, the program is stupid, so that's why you can easily distinguish. But the imitation is fine, I think, right? And then human imitation is fine. So this difference is coming from not by the goodness of imitation, but we think this difference between the Brownian part and then other human possession part is coming from other thing. For example, like author is always try to imitate others, right? But as I said, like the psychological experiment, human possession case is it's not just imitating, but they try to deviate from the imitations. So try to create a new ones, right? So the human behavior is interesting in a sense that they can they can generate a new kind of actions. They cannot just stay, imitating with each other, because one reason is because the human knows the other one is also imitating yourself, so that they do something else, right? They have a metacognition of their own behaviors. So that's one of the reasons, but that's what we thought was interesting. And this data is a transfer entropy from the arms and other body parts. So when you see the calculate the transfer entropy, the two, even if these are two programs, the program the transfer entropy is break up, symmetry is breakdown, and then this case is order in all data, calculating transfer entropy from the all data, that shows order 3 is on the upstream of the information flow, and then order 2 is the downstream of the information flow. So this breakup is like a leading and follower emerges by the from the interactions, and then maybe this uh, causes of this symmetry breaking is because order 2 and order 3 have a different body structures, so that because of this body structures, the constraint is different. That leads to the different behavior of order, even though the program inside the order is the same, exactly the same program, but still body makes it different and then generates leader follower relationship. So concluding from this one, this experiment is that um, the machine's mind is not, for the moment, it's generated by an algorithm by itself, and then it's something different. That so I think I think that the mind can be contagious from people through the interactions. So here from this experiment, this author's program, my answer to Brooks' questions, what is the Brooks juice, is that my answer is that maybe the man machine imitation game can be the Brooks juice. Don't put a robot in the vacuum state, or don't put robot isolated from the environment or human beings. Put humans or living systems coupling with a robot, and then maybe a robot can learn, can interact, and then the mind is copied from the man to robot, so that the machines and artificial life becomes lifelike, I think. But this is like a panspermia hypothesis of human mind. I cannot talk about how the first mind emerges. However, I can talk that the mind can be transferred from human to robot or android, so that android becomes human-like, and that can be possible. That we really have to think about the learning mechanisms. How you can receive this interaction, how you can be um, make mutual engagement with humans. But again, that I remember that Alan Turing's quote from the Computing Machinery and Intelligence paper, but 1950, that considers the human mind that it's not like a skin of onion, that each layer we find a mechanical operation that can be explained in mechanical terms, but we say these layers do not correspond to the real mind. If that is true, then where it is be found? Do we ever peel back on the onion layer and then find the real mind? Yeah, maybe so, right? Even if you have to have a learning devices, our mind is not there, right? It's each peel, the layers of the peels of the onion is the mind, right? That's what the embodied mind is coming from, is my guess. So so this is the last two pages. So I remember that when Andy Clark came to Japan, um, actually this was 2011 311, means that there was a huge earthquake, right, when Andy Clark was giving a lecture to us. And then I was discussing with Andy that how to understand the mind, right? The science of messy minds itself can be the messy science, and that's what we've been discussing, right? um, so there is not like a mind circuit, which if you put into the system, then you can have a mind. I don't think this is not going to happen. But if you have a robot and interact with the robot, then as Andy says, there's he says it's a leaking mind. Mind is not encapsulated in the body, but it's leaking from the body to the outside. And this is also true for the robots. Robot is if he has his mind, it's leaking out of his body and then contagious to human partner. So I think it's something that we have to think about. Not only the cognitive part, but think about the lived part, lived body, and that's something that I am working with, is the possession author and autonomous programmed author to interact with. So finally, this is my lab team that working together to make up this experiment possible. So I very much thankful to those people. Um, and these are the references, and also there's the exhibitions is going on. So if you click to go to the website, then you can find one of the interesting art performance with no theater player and an author is performing together, which we call it Kugus Kagura. It's Mutex Japan, 2020 December 10th, but I think you can find on the website. And there's more that the information you can find on the web, how this author imitation experiment is going on. Thank you very much. This is my talk.
Okay, thank you very much, Takashi. As usual, this is a very, very deep philosophical discussions about what is mind and how this is related to embodiment. Takashi, we have a lot of questions posted in the Discord, so you cannot really go all the questions right now, but perhaps you can come back to this later. So just a couple few questions from my end. So the first question I just wanted to ask you, yesterday we had a discussion with Olaf Sporns about what's the role of a resting state of brain dynamics. And in a possible connection to the daydreaming, the roles of daydreaming. I think these are the highly related issues with what you're talking about today. Do you have any comments about this?
Yes, yes. Actually, when I was listening to what Olaf Spons was discussing, I was actually think, okay, this is it. This is like a the Brooks juice. I don't know, but dreaming mode is important. Usually the robot does nothing when there's nobody's there, or there's no task. But this author, even if nobody's there, he's tried to, explore his own memory and then try to, extend and then play around with his memory structures. That's the dreaming, that the function of dreaming mode. So um, default mode network is very much important for self-organization of minds and then interacting with mindful situations. I think, yeah, that's my comment. Yes.
Okay, yeah, brilliant. I just wanted to make a connections farm between your talk and Olaf's talk. And another potential relationship with your talk is animal AI discussion yesterday. So your talk is mainly focusing on human level intelligence and human kind of perceptions and interactions. I'm wondering to what extent this can be associated with other types of biological organism. You work
Yeah.
on the oil
Yes.
droplets, and
Yeah.
you're working on robots and humans, and mixing all different kind of levels of intelligence. I just want to have a bit of feedback from your
Yeah,
comments on this point.
that's also quite an interesting question that I forgot to tell you this, because first of all, my hypothesis is that human baby born without mind, without having mind, right? But imitating mother's face, like a neonatal, very much a primitive imitation from her mother's face, like a Trebarthen's experiment, that when she laughs and the baby laughs and angries and baby angries, but also when the wolf uh, brought about human baby, and then human baby becomes wolf-like, right? So the first contact with the animal, and if the partner is wolf, then wolf's mind is copying to the human baby. So she never standing up and walk, but she is crawling and moving fast, right? So when so the first imitation game is very important. What kind of mind is coming from your interacting part? And I don't know whether the frog and then other animals interacting with each other, and what kind of mind is copying from each other. But I think this can be possible, and then it changes the way that you move your body, and that means that the mind installed in your system is tightly coupled with your body. It's not the hardware and software is separated from each other. It's inseparable, right? Hardware is partially is software, and software is hardware. And so I think the computer metaphor of human brain is misleading. We have to think about something new, right? Because even if the Macintosh or Windows machine, the same software runs, right? But that's not the case with our brain. So I don't know whether I can answer to your questions, but that's something that I've been thinking of.
Okay, yes. And one question from the Discord. So, what if you include the physical interaction between human and robot instead of just visual interaction as you see here?
Yeah, that's Ota's fault. Yeah, so we are preparing 45 piezo sensors and bending sensors, so that next one we can touching each other, and then there's a physical feedback, right? So this is a phantom limb extension of phantom limb experiment, but it's touching with each other, right? So that's very important. And then actually we wanted to introduce this physical feedback onto the Ota interactions, but it was very difficult, some technical difficulties. But now it's probably it's coming, so I can report that within the near future. Yes.
Are there any fundamental difference in your theory if you include your physical interactions?
That's also quite a good question. I myself, think it's a very different, because the existence of your sense of ownership is very much depending on the physical touching. But also my colleagues, we've been discussing whether that's important or visual feedback is good enough, or maybe more feedback, right? Like weight or touching sensors, and more variety of sensoring input is necessary to have a feedback. Maybe, but I think we need that. That kind of complexity is necessary to make mind is contagious from others. So that's my feeling. Yeah.
Because you need to put some physics in the interactions, because if
Right.
you look at it, you don't feel the gravity, you don't feel the force.
Right.
But this physical media is very important. That's
Yes,
one
I
of the
agree.
points.
I agree.
Right.
That's a very
Okay.
good point. Yes, I agree.
Yeah. Okay, great. So I think this was a good point to break this session. And there are lots of questions in the Discord, and please keep posting your questions if you have. And Takashi is going to show up shortly in Discord. So we're going to continue with discussion later. And Takashi, if you possible, please join the next the panel discussion as well. Once again, thank you very much, Takashi, for a wonderful, inspiring talk. And we're looking forward to continue discussing on this very fundamental.
Thank you very much for attending my course. Thank you very much.
Okay, thank you very much. So we'll see you again in 15 minutes time. So we will start the next panel discussion 10:30 GMT. So until then, we'll see you there. All right, thank you.
Thank you.